Welcome back. And don't forget, we are still on the concept of quadratic equation. Now, we've looked at a lot of things under quadratic, and right now we are still looking at sum and product of roots. And I have told you that the sum of roots alpha plus beta is always equals to minus b over a, and product of roots alpha beta is equals to c over a. So you must take note of this, as it will help us in solving problems of this nature. So which means that you can be given a quadratic equation. For instance, the question says if alpha and beta are the roots of the quadratic equation, 3x squared minus 5x plus 2 equals to 0. Find the value of alpha plus beta, alpha squared plus beta squared, alpha over beta plus beta over alpha, 1 over alpha plus 1 over beta, 1 over alpha squared plus 1 over beta squared, alpha cubed plus beta cubed. Then, for you to solve this kind of problems, you need this, the sum formula, the sum of the roots and the product of the roots. So that's exactly what we are going to be doing. So let's get started. Now, let's pick the first one. Okay, solution. The quadratic is 3x squared minus 5x plus 2 equals to 0. And the first question says find alpha plus beta. So let's analyze it. Don't forget from our general quadratic formula or general quadratic equation that we have a to be equals to 3, b is minus 5, and then c is 2. This is a, b is minus 5, c is plus 2, which is 2. Okay. The first question I says find alpha plus beta. So you have to recall that alpha plus beta is equals to minus b over a. Then carry out your substitution, meaning that alpha plus beta is equals to minus into what is b? B is minus 5. So you have minus 5 all over what is a? A is 3 all over 3. So this is equals to minus times minus is plus. So minus times minus 5 is plus 5 all over 3. That is your alpha plus beta. So you have answered the first part of the question. Now the second part, which is II, says find alpha beta. So you have to recall that alpha beta is c over a, which is equals to, now what is your c? C is 2. So you put 2 over what is a? A is 3. So you have 3. You have finished answering the question. So that is I and that is II. Now, for us to find III, which is alpha squared plus beta squared, from here till this point, that's where we have a little work to do. So I'm going to take my time to explain that. Alright, you will agree with me. Let me write it somewhere that alpha plus beta is 5 over 3. So 5 over 3, and then alpha beta is 2 over 3. So you have 2 over 3. And of course, you saw the process. Very simple. Okay. Let's now move further. Let's work on III. III says alpha square plus beta square. Please take note of this. You don't have, now remember we only talked about sum and product of roots, which is just sum and product. Now that you are asked to find alpha square plus beta square, there is nothing like this. So, but the fact is that inside alpha square plus beta square, there is alpha plus beta and there is alpha beta. So your duty as a student is to break these to be able to obtain your alpha plus beta and alpha beta. So let's go there. First thing is, we can write alpha squared plus beta squared as alpha plus beta all squared. But let me say this is not equals to this, no doubt. But why do we represent alpha squared plus beta squared as alpha plus beta all squared? It is because if you expand this bracket, definitely inside you will obtain alpha squared plus beta squared. Okay, let's see that. For now, we represented alpha squared plus beta squared to be alpha plus beta all squared. So at this point, I don't need this again. I'm now going to make use of alpha plus beta all squared. Look at it here, alpha plus beta all squared. Don't forget I said this is not equals to this, but we represent it this way in the sense that when we expand this, we will obtain this. So now we don't need this again. What we are making use of now is alpha plus beta all squared, which is what is here. Now let us expand this. If you have alpha plus beta times alpha plus beta, remember it is alpha plus beta into two places. Now let's expand. Alpha times alpha is alpha squared. Alpha times alpha is alpha squared. Alpha times beta is alpha beta. Beta times alpha is alpha beta. Beta times alpha is beta alpha, but arrangements you can write alpha before beta, they are still the same thing. Okay, now beta times beta is beta squared. So you can see that this is alpha squared. I'll bring alpha squared and beta squared together plus beta squared plus alpha beta plus alpha beta is like saying 2x plus 2x, which is 4x. 2 mangoes plus 2 mangoes equals 4 mangoes. So the same thing, alpha beta plus alpha beta, which is the coefficient is 1, coefficient is 1, so 1 plus 1 is then 2, then alpha beta, and then plus beta squared. This is exactly, no, sorry. You have alpha plus beta coming together plus alpha beta plus alpha beta is 2 alpha beta. So expanding this is what you get. Okay, so let's do that here. There is a way to expand two terms inside raised to power 2. A very short way of doing it is this. Step 1. This is carry these 2, put on top alpha, so you have alpha squared plus step 2. Use these 2 to multiply the 2 terms inside the bracket. So 2 times alpha is 2 alpha. 2 alpha times beta is 2 alpha beta. Plus, the last thing to do is carry this to put on top beta. So that will give you beta squared. Now, that means that alpha plus beta squared is equals to, bring alpha squared and beta squared together. So you have alpha squared plus beta squared plus 2 alpha beta, 2 alpha beta. Now, you were looking for alpha squared plus beta squared. You can see it here, alpha squared plus beta squared. So you make it the subject of formula by taking 2 alpha beta to this side. So you have alpha plus beta squared plus 2 alpha beta will move to become minus 2 alpha beta equals to alpha squared plus beta squared. And this is exactly that alpha squared plus beta squared we were looking for. So after expanding, this is exactly what we get, which implies that anytime you are looking for alpha squared plus beta squared, always use this formula. You can cram it, or you can know how to derive it just like I have done. In case your cramming fails you, you can generate it for yourself. Okay. So you will agree with me that if I am solving for alpha squared plus beta squared, alpha squared plus beta square. Then I must remember that it is alpha plus beta all square, alpha plus beta all square minus 2 alpha beta. Please never forget this. It helps a lot. So let's use this now to answer the third question, I. So it means that alpha square plus beta square will be equals to alpha plus beta. Don't forget, we've already gotten it from I and I. So alpha plus beta is 5/3. So carry 5/3, put in the place of alpha plus beta. So you have 5/3 all square minus 2 times what is alpha beta? Alpha beta was 2/3. We put it there, 2/3. So this is now simple arithmetic. 5 square over 3 square. That is 5 raised to the power 3 all over 3 raised to the power 2. 5 raised to the power 2 all over 3 raised to the power 2 minus 2 times 2, 4 all over 3. Okay. So this is equals to 5 square is 25/3 square 9 minus 4/3. Okay. So I can clean this. So what do? Now let's simplify that fraction. 25/9 minus 4/3. There is a very simple way to clear fraction or to add or subtract fraction is this. This way, multiply this way over this way. Alright, 25 times 3 will give you 75 minus 4 times 9, 36 divided by 9 times 3, 27. So that will be 75 minus 36 will give us 39 divided by 27. 3 can cancel 39. How many times? 3 here, 1, 3 here, 3, 13. 3 into 27, 9. So by the time you are done, you realize that you obtain 13/9. So that's exactly how to handle this. Now let's move on to IV, which is the fourth one. Okay, for the fourth one, what we have is 1 over alpha over beta plus beta over alpha. So we have alpha over beta plus beta over alpha, beta over alpha. Okay, this is a fraction, just the same way we create fraction. Very simple. So what do? This is equals to alpha times alpha this way, this way, this way. Alpha times alpha is alpha square plus beta times beta is beta square all over alpha times beta, alpha beta. Now if you look at the numerator, we have alpha square plus beta square, and I told you to memorize this. So anywhere I see alpha square plus beta square, I'll comfortably drop. In the place of alpha square plus beta square, I will drop alpha plus beta all square minus 2 alpha beta. Don't forget that. Divided by alpha beta. So at this point, you can substitute the values, which is equals to, what is alpha plus beta? Alpha plus beta is 5/3 all square minus 2 into, what is alpha beta? 2/3, 2/3 divided by alpha beta. So this is 5 square 25/3 square 9 minus 2 times 2, 4 all over 3. Okay, divided by alpha beta, which is 2/3. 2/3. So this is equals to, now don't forget that we had earlier simplified this numerator, and what we obtained was 13/9. So having To simplify this, you have 13 over 9, then divided by 2 over 3, 2 over 3. So you can remember from your primary 4 or 5, whatever class, you said this is 13 over 9 divided by 2 over 3, 2 over 3, which is equals to 13 over 9. Division will change to multiplication. Then you invert this fraction. 3 will go up and 2 will come down. So this will now give you 3 here, 1, 3 here, 3. So you have 13 times 1, 13, divided by 3 times 2, 6. So that is your value for alpha over beta plus beta over alpha. I hope that is very simple and straightforward. Okay, let's look at V. Let's look at V. Now V says I should find 1 over alpha plus 1 over beta, 1 over alpha plus 1 over beta. Of course, this is very simple. It's a fraction. So let's clear the fraction. Okay. Alpha times 1 is alpha plus alpha times 1 is beta plus beta times 1 is beta all over alpha times beta, which is alpha beta. Very simple. You are done. So what is your alpha plus beta? 5 over 3. So you put 5 over 3 divided by alpha beta 2 over 3. 2 over 3. So this is 5 over 3. Division will change to multiplication. Then 3 will go up, 2 will come down. You have 3 over 2. So 3 and 3 will go. You are left with 5 over 2. You are done. It is as simple as that. And then VI says we should find VI says, okay, what is it? Okay, so we should find 1 over alpha square plus 1 over beta square. Very simple, just the same thing, clear fraction. Alpha square times 1 is alpha square plus beta square times 1, beta square, all over alpha square times beta square is alpha square beta square. This times this is this. So this is equals to, now from indices we say that if we have AB raised to power x, that when this power x comes into the bracket, it will affect both the power of A and the power of B. So you have A raised to power x and B raised to power x. So which means that if the powers are the same, all I have to do is multiply the bases, that is A times B, which is AB, raised to power 1 of the indices x, and to turn back to this. So in the light of that truth, what we are going to do is, now don't forget first of all that alpha square plus beta square is alpha plus beta all square minus 2 alpha beta. Just know it. Divided by alpha square beta square will be alpha beta all square. From that concept I just explained. So from here we can now say that this is equals to, what is alpha plus beta? It is 5 over 3 here, square minus 2 into alpha beta is 2 over 3, divided by alpha beta 2 over 3, 2 over 3 raised to power 2. Okay. Now remember that we have already simplified this numerator previously, and the answer was 13 over 9 divided by 2 square, which is 4, all over 3 square, which is 9. So this is equals to 13 over 9 divided by, which will now change to multiplication. Then 9 will go up, 4 will come down. You have 9 over 4. So this is 9 and 9 will go. You are left with 13 over 4. You are done with that. Now let's look at alpha cube plus beta cube. I'll leave the last one for you to attempt on your own. Okay. All right. So the last one says, which I want to do is alpha cube plus beta cube. Okay. Alpha cube plus beta cube is equals to, now remember when we had alpha square plus beta square, I will write this as alpha plus beta raised to power 2. So in alpha cube plus beta cube, I'm going to write it as alpha plus beta raised to power 3. Good. So my job now is to expand this. So I'll write it. I'm not interested in this anymore. Why? Because after expanding this, I'm going to obtain this. So this is where I'm interested in, which is alpha plus beta cube. And it is equals to, now this is binomial expansion of power 3. If you watch my video on binomial expansion, you really understand this, but I'm going to apply it. Now, in expanding this, there are two terms. First of all, carry this 3, put on top alpha. So you have alpha cube plus. Now, remember there are two things here. So, for as long as this is alpha cube, the rule is this. The power of alpha will keep reducing from power 3 to 1, 0. So let's go there. I'm going to have alpha cube plus alpha square plus alpha raised to power 1 plus alpha raised to power 0. Okay, in the next line, I'm going to bring in beta. So that will be alpha cube, beta will start with 0. Okay, plus alpha square, beta will now increase from 0 to 1 plus alpha raised to power 1, beta raised to power 2. 0, 1, 2, okay, plus alpha raised to power 0, beta raised to power 3. So you can see that alpha raised to power 3, from 3 it will now decrease from 3 to 1, 0. Whereas alpha will come in and start from 0, 1, 2, 3. Watch my video on binomial expansion. You really understand this. Okay, let's finish it. So this will now be alpha cube. Okay, alpha cube, beta raised to power 0. Anything raised to power 0 is 1. So this is gone. Plus alpha square beta plus alpha raised to power 1 is the same thing as alpha, then beta square plus alpha raised to power 0 is 1 times alpha times beta cube, which is beta cube. Okay, we are going to introduce Pascal's triangle to obtain the coefficients. And in Pascal's triangle, please watch my video on binomial theorem, you will understand. For power 1, for power 0 it is always 1. For power 0, for power 1 it is always 1, 1. That is power 1. For power 2, it is always 1 plus 1, 2, then 1 at the extremes, and you have power 2. For power 3, 1 plus 2, 3, 2 plus 1, 3, 1, 1. That is for power 3. We use this to obtain the coefficient of a binomial expansion. Okay, so 1, 3, 3, 1. So you come here and drop 1, 3, 3, 1. Now, take alpha cube plus beta cube close. So you have alpha cube plus beta cube. Okay, plus. Next, you are going to factorize. 3 is common, you factor out 3. Alpha is here, you bring out 1 alpha. 1 beta, you bring out 1 beta into. Now, since you've taken out 3 and 1 alpha, you are left with 1 alpha now here. Remember, beta is gone because it is here, okay? Plus If you come here, you took 3 and alpha out, and then you pick one beta out, you are left with just one beta. So from here, what we have is this. This is what you have, that alpha plus beta cube is equals to alpha cube plus beta cube plus 3 alpha beta into alpha plus beta. Now, you make alpha cube plus beta cube the subject of formula because that's exactly what you were looking for. That means that you have alpha plus beta cube. Now, plus 3 alpha beta into alpha plus beta will move to this side to become minus 3 alpha beta into alpha plus beta, which is equals to alpha cube plus beta cube. So it therefore means that anytime you want to make use of alpha cube plus beta cube, you must know it that it is alpha plus beta cube minus 3 alpha beta into alpha plus beta. This is something to remember, something to always remember. Very, very important. Okay, so now let us solve the problem that was given to us. And the problem was that we should find alpha cube plus beta cube. So it therefore means that alpha cube plus beta cube is equals to, let's substitute. Alpha plus beta is 5 over 3. So here you put 5 over 3 raised to power 3 minus 3 alpha beta is 2 over 3. So you put 2 over 3 times alpha plus beta 5 over 3. You put 5 over 3. This is now simple arithmetic. Okay, so this is going to be equals to 5 cube is 125 all over 3 cube 27 minus this 3 will cancel this 3. Okay, so you are left with 2 times 5 10 all over 3. So the next thing now is find the LCM. The LCM definitely will be 27. So you have 27. Now 27 goes into 27. 1 times 125 is 125. Minus 3 goes into 27 9 times. 9 times 10, 90. So you have 125 minus 90. That is 5, 12, 3. That is 35. Okay, so you have 35 over 27. And it therefore means that 125 minus 90 is 35 divided by 27, which we can leave it there. So that's exactly how to apply this in solving problem. Now the last problem I'm going to solve for us is that, or let me say, well, the last thing I would like you to know is that you can still use this sum and products of roots, and using the quadratic formula, that is the formula for forming a quadratic equation, to form a new equation given that the root of that equation is alpha and beta. So I'm going to use one example to illustrate that for you. Stay tuned till I come your way. Thank you.
Mathematics tutorial with Emma Johnny.